This is problem 13 from chapter 15. In problem 13, we have a 2.5 megagram van traveling with a speed of 100 kilometers per hour when the brakes are applied and all four wheels lock. If the speed decreases to 40 kilometers per hour in 5 seconds, determine the coefficient of kinetic friction between the tires and the road. So we have in problem 13, the mass is 2,500 kilograms. Velocity 1, they are giving it to you in kilometers per hour. This is 100 kilometers per hour. To convert it to meters per second, change the kilometers to meters, and there are 3,600 seconds in an hour. That gives us 27.78 meters per second. For V2, we had 40 kilometers per hour. Converting that to meters per second gives us 11.11 meters per second. Delta T is equal to 5 seconds. We want to find the coefficient of kinetic friction. The brakes are applied and the wheels lock. If the wheels are locked, they are not rotating, and so they're sliding relative to the surface, which means that we have kinetic friction. Since this is in chapter 15, we are using our impulse-momentum relationship, which is here. The force of kinetic friction is constant, so it can come outside the integral. I can bring the mv1 over to the other side and write this as F net times delta T is equal to the mass times the change in velocity. This is our impulse when the force is constant is equal to the change in momentum. I have my mass, I have my initial velocity here, my final velocity here. So this is initial velocity minus final velocity. And let's draw a picture here. They had the car going the other way in the book, but let's say the velocity is going this way since I called it positive here. So if the velocity is to the right, then the force of friction must be acting in the opposite direction. So we have force of kinetic friction to the left. This is the only force that we have acting in the horizontal direction. So if you use the impulse-momentum relationship in the x direction, I have my net force, which is just the force of friction, acting in the negative direction, times delta T. For the force of kinetic friction, if I look in the vertical direction, I have the force of gravity acting downwards. I have the normal force acting upwards. Those are my only forces in the y direction, and so the force of gravity is equal to the normal force. So the force of kinetic friction is equal to the coefficient of kinetic friction times the force of gravity. So on the left-hand side of the equation, I have UK, which is what I'm looking for, times the mass, times G, times delta T, which is 5. And so I should be able to solve for the coefficient of kinetic friction. And if I do that, I have 2500 1.11 minus 27.78, which is going to be negative. And what I should have done here, since this was a vector equation, the force of kinetic friction is acting in the negative direction. So I should have put the sign in there. If that's negative, then we can bring that over there. This whole thing will be positive. Then divide this by 2500 times 9.8 times 5. And you should get 0.340 for the coefficient of kinetic friction. And that concludes problem 13.